Hey everyone, my name's Erica Webb, and I chose to do my lecture topic on meat fermentation. So, what is meat fermentation? Fermentation, by definition, is the process by which certain microorganisms and bacteria are added to the meat and allowed to metabolize. During this metabolism process, these bacteria generally emit certain chemical byproducts, and that overall affects the texture and flavor of a piece of meat. After the fermentation process, the meat is allowed to age and it dries. And the drying process helps to remove water and helps preserve the piece of meat. This shouldn't be confused with meat curing, which I'm not going to really discuss today, but by definition, that's changing the amount of water that's held in the cells of a piece of meat, and that's done by adding salts and sugars. And it's still a process that can be used to prevent microorganisms from growing and helping preserve the meat overall. So before we even begin fermentation, we take a piece of meat that has been removed from a carcass and remove all the excess trimmable fat and the tough connective tissues from it. We then take that piece of meat along with a bunch of other meat, chop it up, grind it up, and add a whole mixture of different salts and sugars and spices. We're also adding fat back into the mixture, which is going to help the overall consistency and is going to allow for a certain process to take place, which will be talked about in a little bit. The combination of what we add to this meat is all dependent on what our desired outcome would be. Different additions to this meat is going to allow for different microbial processes to take place. Salt's generally added to this mixture. It allows the muscle tissue to kind of melt and for those myofibrillar proteins to solubilize, and it gives kind of an overall sticky, consistent texture. So the mixture is then going to be stuffed into casings to give the sausage its form and allow to go through its fermentation process within those casings. Once we have our sausage made up and into the casings, we're going to put them into a temperature-controlled, climate-controlled room, and the temperature is going to be raised from -2 degrees Celsius, sometimes up to 35 degrees Celsius, depending on the sausage. And there have been a few different types of products that the temperature is even increased up higher than 35 degrees Celsius. There's a couple different types of fermentation, but a few key words is dry fermentation, which is fermenting at a lower temperature for a longer period of time, or we've got semi-dry fermentation, which is more of a quick fermentation that's done at higher temperatures. So the overall process of meat fermentation can be fairly complex. There's a lot of different ways to do it. Sometimes fermentation can last from less than 12 hours up to several days. And after you add the whole aging and drying process, it could take several weeks. But the general idea of fermentation is we're taking good bacteria and adding it to the meat and allowing it to replicate. It's going to break down these harder muscle structures, and during the breaking down of these structures, we're going to be producing acidic compounds. This is going to lead to proteolysis and lipolysis of proteins and lipids, and that's going to affect the overall taste, firmness, keepability, and aroma of the end product. So during production, typically our pH is going to decrease. The average is going to decrease to about a pH of 5. Sometimes the acidity can decrease to as low as 4.2 for some sausages. And a lot of that has to deal with what we put into our sausage, the type of starter culture we use, and most of the time, without the addition of certain carbohydrates such as sugar or glucose, our pH isn't going to drop below 5. Temperature also has a lot to do with the pH. Typically, meats that are fermented at higher temperatures are going to lead to a lower pH. And then once we want to jumpstart our fermentation process, typically it's done by lactic acid bacteria, which is the main component of most starter cultures. I'm not going to discuss too much of backslopping, but backslopping is an older method that was used in some other cultures. It's not used as much anymore, but I'm sure there are some places that still do use it. But that's pretty much taking a bunch of meat that already contains the necessary bacteria and microorganisms in it, and taking a portion of that and putting it into a newer batch of meat mixture, and allowing it to ferment using the older bacteria, and that just allows for a more consistent product from sausage to sausage and from batch to batch. So overall, fermentation is an anaerobic process, so no oxygen is needed. Lactic acid bacteria is used to start carbohydrate fermentation. I'm sure a lot of you have already taken biochemistry, but carbohydrate fermentation is done through glycolysis, which is the breaking down of glucose. Glucose is then converted to pyruvates, which is then converted to lactate. And that lactate, along with a bunch of the ATP that was produced during this process, is going to be used to by these microorganisms to emit certain chemical products that create the overall certain aromas and tastes that we get from fermented sausages. Like I said, lactate is the main end product of lactic acid bacteria fermentation, but ethanol and propionic acid are other end products as well. So there are a bunch of other processes that are going on, depending on what kind of microorganisms we use and what kind of starter cultures we use, but glycolysis is the most common and the largest one that's going on throughout the fermentation process. We also have the fermentation of fatty acids and amino acids, and those yield a whole different realm of flavors and aromas. And generally, the whole process of fermentation ends at the completion of lactic acid fermentation. So lactic acid bacteria is going to be the essential agent of meat fermentation, and it's going to be the major bacteria that prevents spoilage and pathogen growth. It also, because we're fermenting carbohydrates, it causes a lot of acidification of the meat, and this leads to an overall better improvement of color and texture. Lactic acid bacteria also helps to aid in the release of volatile and non-volatile compounds, which helps to degrade free fatty acids and prevents oxidation. Some of these compounds include alcohols and aldehydes. Non-volatile compounds include amino acids, peptides, sugars, and nucleotides. And these combination of these compounds is really important for flavor quality. Some of these compounds come naturally just from the raw materials that we use. Some of them are naturally found in the meat. Some of them are found in the spices that we use, or just as a result of the whole fermentation process. So lactic acid bacteria is pretty important for a lot of different things. Here we're discussing its use in the food industry, but it's also pretty important for medicine and other chemical compounds. The byproducts of lactic acid bacteria lead to probiotics. We use them in starter cultures. They can be used for antimicrobial agents. They also produce a bunch of different enzymes and vitamins, and a lot of those are used for fermentation. So proteolysis is the degradation or the hydrolysis of proteins, and this overall has an influence on different molds and bacterias, because these molds and bacterias use the enzymes that are produced from the breakdown of proteins, and that's directly related to the taste and the aromas that are put off. So proteolysis is not always due to the enzymes in these proteins are not always related to time and temperature. Sometimes proteolysis can happen without enzymes, and certain enzymes such as cathepsin D-like enzymes occur during proteolysis and can lead to higher peptide and amino acid contents. So lipolysis is the degradation or hydrolysis of fat. Fat is generally added to meat mixtures at a ratio of 2 to 1, and that's just for most industrial sausages. It changes depending on where you go. But lipolysis of fat breaks down glycerol and triglycerides into free fatty acids, and staphylococci is one of the main substances used to do this. Heat does affect the formation of free fatty acids and therefore the rate of lipolysis. And overall, we want to, this is really important because we want to avoid an excess of lipid oxidation, which leads to the spoilage of food. Different types of meat, such as beef versus pork versus chicken, affect the rate of oxidation. And overall, this is pretty important to understand because fat plays such a huge role in the flavor and texture of sausages. So this is just a graph that explains how time and temperature affect pH. So in a slowly fermented sausage, we're going to have probably a lower temperature. It's not going to decrease to a pH much lower than 5.3, and it happens a little bit slower than your medium and fast fermented. It's going to level out probably about 8 hours and not drop a whole bunch over the next few days. Medium fermented sausage is going to decrease in pH a little bit faster rate, kind of bottom off around 8 hours, but it decreases in pH a little bit quicker. Our fast fermented sausages are going to drop in pH relatively quickly and kind of become more consistent between hour 2 and 3. So in most manufacturing facilities, lactic acid bacteria and staphylococcus are generally the main types of bacteria used in starter cultures. Most of these have been genetically modified to improve their hygienic and sensory qualities that are produced. A large quantity of these don't have to be added because lactic acid bacteria has an extremely fast growth rate, and lactic acid bacteria is typically the most dominant, which is a positive because it helps weed out potentially harmful bacteria. An increase in lactic acid bacteria is generally correlated with a decrease in pH, which is what we want, as long as the pH doesn't get too low. We want to keep a low pH because a higher pH is typically associated with an increase of molds. Fermented products can be made without starter cultures, but the use of starter cultures helps provide a really consistent product and kind of an insurance policy to ensure the safety and provide just an overall consistent product for the consumer. So there are a bunch of factors that affect starter culture performance. Typically sausages are heterogeneous, so they're created with a bunch of different things. So every sausage is a little bit different. And because of that variation, we can have different effects of starter cultures on these sausages. So microbes can impact each piece of meat differently, and altering the combination of these microbes can result in different metabolic behaviors. These metabolic behaviors can affect taste and aroma and the texture of the meat. There are a bunch of extrinsic and intrinsic factors that we can manipulate in order to steer the microbial fermentation process to what we want. A lot of these have to deal with the variations in the properties of a piece of meat. Overall nutrient availability and the pH of a piece of meat is going to affect how microbes react to it. Also, the amount of fat that we add to our mixture affects the dehydration process, and overall affects microbial equilibrium. The amount of salt that we use or the curing agent is going to affect how these microbes grow and ferment as well. So natural microbial species vary between animal species and between breeds. It's important to know what's in our starter culture before we use it to make sure that we complement the type of meat that we're using along with the other additives that we're adding to that mixture. It's important to understand what we're putting into it because we need to be able to optimize the metabolic processes, and that's vital because we want to prevent as much spoilage and the growth of pathogens as possible. In a few studies, it was seen that freezing raw meat for a few days prior to sausage fermentation actually helps kill off some of these harmful bacteria, which could be beneficial. So there are a lot of things that can influence our starter cultures. The amount of fat that's in our mixture definitely affects our starter culture. The amount of fat that we put in typically contains naturally some lactic acid bacteria. So if we're adding a bunch of fat, we might not have to add as much lactic acid bacteria. But if we're using a meat mixture that doesn't have a lot of fat, then that lower fat content has been shown to increase pH and water holding capacity, which leads to a higher risk of undesirable microbial growth. The amount of fat also encourages the production of free fatty acids, and that's really important because we need to be able to select for certain lipid-based flavors, which leads to overall more desirable consumer perception. The amount of fat can also decrease bactericin levels. That's because fat has absorbing properties that can absorb certain molecules. And temperature has a huge influence and is probably the most important determinant of microbial performance. That's because the thermodynamic effect on these microbes affects the growth rate and the amount of enzymes that they emit. So temperature is also determined based off the cultures used. Certain microbes deal with or are affected by different temperatures in different ways, and we need to be able to select the temperature that's going to allow that microbe to grow and metabolize optimally. We can induce a faster growth and acidification through increased temperatures, but overall this could affect quality, and we don't want something to potentially grow bad bacteria or not ferment correctly. So starter cultures are also influenced by the amount of fermentable carbohydrates we add to the mixture. This determines the extent of the acidification of the product, and that overall determines the end product pH. Of course, we don't want to get something too acidic because that affects the taste of the product. Salting and drying influences our starter cultures. Water availability is really important for microbial growth, but decreasing water holding values does select for microbes specifically needed for fermentation. So we want to make sure that we have enough water that our microbes can grow, but we also eventually want to dry our product to where these microbes aren't going to continue growing after we're done fermenting, which we'll discuss in Lecture 2. So we can modify the salt content, and that influences microbial selection. There is an influence in what the consumer wants and need. They're typically looking for lower sodium containing products, which can be kind of difficult because we need the salt in order for these microbes to grow. An increase in salt generally inhibits staphylococcal activity, but too little salt increases lactic acid production, which decreases the pH, and negatively affects staphylococcal growth, which decreases the production of volatile compounds. So having an optimal salt content is vital to proper pH levels and microbial growth and fermentation. There is an influence of the spices that we put in. Certain spices can act as antimicrobials, and oregano is one of those, which has been shown to inhibit surface fungi. We can inhibit or promote activity of certain starter cultures by using spices, so we need to be careful about making sure we use certain spices and additives that enhance our culture, not inhibit them. Some spices can stand alone and be effective without the addition of other cultures, and understanding the effect of these processing factors and what they have on microbial growth leads to overall better control of our end product of fermentation and results in higher quality meats. So in the next lecture, I'll go over more of what just overall consumer wants and needs, along with some more information about good versus bad bacteria and some of the drying processes that affect our overall sausage product, end product.